Welcome to Laos Air Moving School. The Air Moving School was originally developed in 1972 as an educational resource for wholesalers and contractors in the HVACR industry. Now in its 50th year, the Air Moving School is recommended for anyone who wants to learn more about HVACR replacement parts and their applications. The history of Laos starts in 1928 when Edgar B. Lau patented the press lock blower wheel. The press lock wheel design has stood the test of time and is still in use today for our belt drive wheels. In 1932, Edgar Lau founded the Lau Blower Company in Dayton, Ohio. In 2018, Lau was acquired by Morrison Products, the leading manufacturer of direct drive wheels for the residential furnace market. We are a woman-owned business certified by the Women's Business Enterprise National Council. Lau Parts has offered universal replacement parts to HVACR wholesalers for over 60 years. We are the only manufacturer dedicated to the aftermarket. We operate 8 manufacturing and distribution facilities in North America, 5 in the United States and 3 in Mexico. Lau Parts operates one warehouse in Dayton, Ohio, with 50,000 square feet of space for stocking our full range of products. Lau Parts utilizes manufacturers' rep agencies located across the United States. Our longest-serving agency has represented Lau since 1967, and all of our reps are experts in Lau products and they understand the needs of wholesale distributors. To find your Lau Parts representative, go to lauparts.com, click on Rep Locator, and then select your state from the map. Lau Parts distributors are in every U.S. state with the highest concentrations of distributors in those areas where population is concentrated. In addition to the warehouse, our Dayton facility contains our technical center with design and documentation resources, as well as a 30,000 square foot AMCA accredited laboratory. Our lab is AMCA 210 certified for airflow, which is measured using our 2 wind tunnels. The lab is also AMCA 300 certified for sound, which is tested in our reverberant chamber. As the only manufacturer dedicated to supporting the needs of wholesalers and contractors, Lau has built a reputation for quality and dependability. Our universal replacement parts are specifically designed to keep SKUs to a minimum, which saves inventory space and reduces inventory dollars. Our parts are designed to endure rugged handling and work in the widest variety of applications. Lau replacement parts withstand the increased workload expected in replacement applications through years of service. Like you, we are in the urgency business. We understand that when equipment is down, you need parts fast. Our replacement parts inventory can't be beat. Before we get into the specific parts that Lau offers, we're going to build our knowledge of how HVACR systems work, starting with definitions of key terms. CFM, or cubic feet per minute, is the total volume of air that a system moves per minute. It is important to understand that fans are essentially pumps for air. Water pumps are designed to move a minimum amount of water, such as a pump in a swimming pool that moves water through the filter. The amount of water that can be moved is limited because water has volume and mass, or weight. Air also has volume and weight. We don't always recognize this because we are surrounded by air, and we don't notice the weight of the air around us. One way to demonstrate the mass of air that most of us have done at some point is to roll down the window when driving, cup your hand, and hold it outside the window. You will feel pressure on your hand that wants to push your hand back. That is the weight of the air that you are feeling. Just like water pumps are designed to move a minimum amount of water, fans, which are air pumps, are designed to move a minimum amount of air. Static pressure is the measure of the total resistance, both positive and negative, to airflow in a system. The push of the air in a system must be greater than the resistance in a system for air to circulate through the ductwork. Static pressure is measured in inches of water gauge, shown as IWG, or as inches of water column, shown as IWC. I will use both terms interchangeably in this presentation, as both terms are used in our industry. Static pressure occurs when something either creates or removes restrictions to the flow of air in a system. For example, the furnace filter restricts the amount of air that can pass through the fabric of the filter. To measure static pressure, we add the absolute value of the positive and negative static pressure in the system. In the image shown on this slide, we take the negative ½ inch static pressure on the intake side and the positive 0.3 inch static pressure on the exhaust side. Remove the plus and minus signs, add the two numbers together, and we get 0.8 inches of total system static pressure. RPM is revolutions per minute. This is the number of times the motor shaft completes a full rotation each minute. bhp is brake horsepower. This is the mechanical horsepower of the motor available at the shaft at specified RPM and at full load current. Note that no fan is 100% efficient. Next, we will look at common applications for HVAC parts. This diagram shows a typical residential heating and cooling system with forced air gas heat. This shows the location of the furnace blower, which is used to move air when heating or cooling the home. Above the blower is the gas heat exchanger, which is used in heating the home. Next is the evaporator coil, often called the A coil due to its shape. The A coil is the indoor part of the two-part air conditioning system. The other part is the outdoor condenser, which is not shown in this image. Here we see the components of the residential furnace. This image shows both electric and gas heat for comparison. Today, most residential furnaces use direct drive blowers. We will look at the difference between belt drive and direct drive later in this presentation. This slide shows the components of the outdoor condenser for a residential air conditioning system. Number 3 on this illustration is the fan blade or propeller. Air handlers are used in commercial and industrial applications. These are the units that you see on the roofs of buildings. In addition to heating and cooling components, the air handler may provide for humidification or dehumidification or energy recovery. The blower shown in the bottom right corner of this slide is an example of a belt drive blower for an air handler application. As we continue building our knowledge of how HVAC systems work, it's important to have a basic understanding of the fan laws and why they matter for replacement parts. Think of the fan laws as a three-legged stool. If you make one leg of the stool shorter, the stool won't be able to stand. If you make one of the legs longer, it won't be able to stand. The three legs of our fan law stool are RPM/CFM, static pressure, and horsepower. Just like all three legs of a stool must be kept in proportion for the stool to function, we must consider all three fan laws when making changes to a system. We'll go through these laws individually, then we'll look at how to apply to a specific situation, then we'll show you the easiest way to work within the fan laws. The first fan law says that RPM and CFM are directly proportional to the change in speed of the fan. The RPM of the motor determines the speed, and it is logical that a faster moving fan would move more air. The second law states that the static pressure is proportional by the square of the change in the CFM or RPM. We will look at specifically what this means shortly. The third law says that the horsepower is proportional to the cube of the change in the CFM or RPM of the fan. At this point, the math starts to look complicated, but let's walk through an example to look at these fan laws in action. In our example, we have a fan that is currently producing 1200 CFM of air. The motor RPM is 1081. The contractor wants to increase the CFM to 1500. This could be to increase the comfort of the homeowners or to comply with the building code for commercial applications. Let's look at the math. We know that the RPM and CFM are directly proportional to the change in the speed of the fan. To calculate the new RPM, we multiply the current RPM by the result of dividing the new CFM by the old CFM. This gives us a new RPM of 1351. The first change we need to make to achieve the desired 1500 CFM is to increase the RPM to 1351. We know that the second fan law says that the static pressure is proportional by the square in the change in CFM or RPM. Our current static pressure is 1 inch. To calculate the new static pressure, we will multiply the existing 1 inch static pressure by the square of either the new CFM divided by old CFM or the new RPM divided by old RPM. We can use either CFM or RPM in this calculation, but we must divide CFM by CFM or RPM by RPM. We can't mix RPM and CFM in the formula. In this application, whether we use CFM or RPM in our calculation, we get the same result. Our new static pressure is 1.56 inches water gauge. Finally, we must look at the third leg of our stool. We know that the third fan law says that the horsepower is proportional to the cube of the change in the CFM or RPM. Just like with the static pressure calculation, we can use either CFM or RPM, but we can't mix the two. Our current horsepower requirement is 0.44 horsepower. In this case, we can assume the current application is using a half horsepower motor because we can always round up in horsepower, but we can't round down to a lower horsepower motor. To calculate the new horsepower, we will multiply the current horsepower requirement by the cube of either the new CFM divided by old CFM or the new RPM divided by old RPM. Either will give us the new horsepower requirement of 0.86 horsepower. Our half horsepower motor will no longer work for this application. To summarize, increasing the CFM from 1200 to 1500 required us to increase the RPM and horsepower, and it resulted in higher static pressure. All three legs of the stool are now in proportion. I mentioned at the beginning of this section that I would show you an easier way to work with the fan laws. The easiest way is to download the Lao Fan Law Calculator app. This app is currently available in the Google Play Store and is coming soon to the Apple App Store. Simply enter your current CFM, RPM, static pressure, and horsepower. Use the lock button to set your initial numbers. Now you can change any of the numbers individually to see the change in the others. Now let's look at Lao's products in more detail. We will follow the order in which these products appear in our catalog in case you would like to follow along in your copy of the Lao catalog. We will start with axial products, which are propellers or fan blades. Note that I will use the terms fan blade, blade, and propeller interchangeably, as these terms are all commonly used by contractors. Free air propellers are designed for applications where static pressure is virtually zero. Free air blades can be recognized by their round blade shape. Typical applications for these blades include pedestal fans and exhaust fans, where the only restriction to airflow is a protective wire guard to prevent injury. Free air blades are efficient and low noise due to the blade shape. However, they cannot be used in condenser applications. Condenser propellers are designed for medium to high pressure applications, such as condenser systems, power roof ventilators, and rooftop air conditioners. Condenser blades can be recognized by the squared shape of the blade. Condenser blades are used in most residential condenser systems. Condenser blades can be used in free air applications if no free air blade is available. Swept or Cobra propellers are designed for high efficiency systems. Swept blades can be recognized by their unique pointed blade shape. Swept blades may also be referred to as samurai blades. Swept blades are often found in high-end residential applications where noise is a concern. Always replace a swept blade with a swept blade. Condenser blades are not acceptable replacements for swept blades, but you can replace a condenser blade with a swept blade if noise or vibration are issues. Other Axial products Lau offers include heavy-duty and extra heavy-duty fan blades available in 3, 4, and 6 blade styles with diameters ranging from 24-inch to 60-inch. Agricultural propellers are available in both stainless steel and aluminum materials in 36-inch and 48-inch diameters. Our EconoFlow propellers are direct OEM replacement blades with half-inch fixed hubs in a variety of diameters and pitches. Small fixed hub and one-piece propellers are designed for use in fan coils, heaters, small appliances, freezers, and refrigerators. Lau's aftermarket fan blades are labeled with an easily understood part description, with number of blades, diameter, pitch, rotation, and bore size if applicable. However, when replacing an OEM style blade, it may be labeled with a long form description, like the descriptions shown on this slide. For assistance ordering a universal replacement propeller, make a note of the description printed on the label on the blade you are replacing. Then reach out to our customer service team. We will be happy to help identify an acceptable replacement. When replacing a propeller, it is important to correctly determine the rotation of the blade. There are several methods for determining rotation, but we find the easiest to be the sandbox method. To determine rotation, imagine placing the propeller in a sandbox with the discharge side facing up. Now determine which direction you would have to turn the blade to screw it down into the sand. If you would have to turn it to the right to screw it into the sand, the propeller is clockwise rotation. If you would have to turn it to the left, then it is counterclockwise rotation. If you were to turn a clockwise blade in a counterclockwise direction, you would simply smooth out the sand. You can only screw the blade into the sand by turning in the correct rotation. To determine the blade pitch of the propeller, use a Lau pitch gauge. The proper method for measuring pitch is to turn the propeller over and measure using only the spider or center structure of the blade. Place the foot of the wire body of the gauge as close as possible to the center of the spider. For a fixed hub propeller, place the foot next to the hub. Position the faceplate of the gauge on one arm of the spider. Turn the faceplate until the gauge is flush with the spider arm. Read the gauge to determine rotation and pitch. Do not measure pitch using the blades of the propeller. Use the spider only. The blades are curved, and this curvature can result in incorrect measurements. The spider arms are flat, and measuring using the spider only will be more accurate. Most LAO replacement propellers have a hex opening in the center of the spider instead of a fixed hub. Hex hubs are available in bore sizes from 1/4 inch through 3/4 inch. The hex hub is affixed to the propeller in the field. This design allows wholesalers to reduce SKUs and inventory dollars. Instead of carrying each diameter and pitch combination with 6 different bore sizes, our universal replacement propellers allow wholesalers to carry only one propeller in each diameter pitch combination and pull the hub needed from inventory that can be shared by all universal fan blades. For our large heavy-duty and extra heavy-duty propellers, we offer taper lock type hubs. The taper lock hub is designed to work with the heavier material weight of the larger fan blades. Our EconoFlow direct OEM replacement fan blades have 1/2 inch fixed hubs. There are several reasons for replacing the fan blade when you replace the condenser motor. Fatigue from the normal stop and start forces can weaken the propeller over time, eventually leading to failure. The balance of the propeller is very sensitive. In fact, LAO propellers are balanced after the product labels are applied. Normal handling of a propeller at the worksite can affect balance, and poor balance can burn out a motor before its time. Even the process of removing the fan blade to service the unit can cause distortion. When a motor is replaced and the old fan blade is installed on the new motor, the result is often failure that results in expensive callbacks. Callbacks average 10 times the cost of the initial service, and that cost comes out of the contractor's pocket. Replacing the fan blade every time the unit is serviced gives customers visible evidence of a repair and leads to increased customer satisfaction. To replace a propeller, make note of the number of blades, diameter, pitch, and shaft diameter, along with any available performance requirements. Refer to the LAO replacement propeller chart at your local wholesaler or Appendix A in your LAO catalog to confirm performance of the replacement blade, or contact your LAO sales representative or our customer service team for assistance. There are times when you may not have the specific fan blade you need in stock, and you need to find an acceptable alternative. For example, you may need a 3-blade propeller, but only have 4-blade propellers in stock. To find an acceptable alternative, first determine the CFM requirements, the horsepower, and RPM of the existing motor, and the static pressure. If the static pressure is unknown, use 0.3 inch. Identify potential replacements of the same diameter and within plus or minus 3 degrees of pitch. Confirm that the replacement blade will provide the minimum CFM without overloading the existing motor. Bear in mind that condenser air is exhaust air, so it is only necessary to meet a minimum air requirement. In this example, you need to replace a 3-blade propeller, 18-inch diameter, 30-degree pitch. The current motor is a 1/4 horsepower, running at 1075 RPM, and we are assuming 0.3 inch static pressure. In the top chart, we see that the 3-blade replacement, which is not in stock, has a horsepower requirement of 0.22 and delivers 1582 CFM at 1075 RPM and 0.3 inch static pressure. In the bottom chart, we have a 4-blade propeller that is in stock. The diameter is 18 inches and the pitch is 27 degrees, which is within 3 degrees of the 3-blade propeller. At 1075 RPM and 0.3 inches static pressure, it requires 0.216 horsepower, which will not overload our motor, and delivers 1657 CFM, which exceeds our minimum requirement of 1582. This 4-blade propeller is an acceptable replacement. There is a common misconception that universal replacement propellers are too heavy since they are made of thicker material than the original OEM blades. Referring to our three-legged stool illustration from the fan laws discussion, you will notice that weight is not one of the legs of our stool. This is because the weight of the fan blade is not the countervailing force. The power to drive a fan is related to its resistance to air, not its weight. The weight of the blade pushes down vertically with gravity, but the force of the motor pushes horizontally. Low's universal replacement propellers have been used successfully by contractors for over 60 years. They are designed to work in a wide range of applications and to withstand rugged handling. The weight of the propellers is simply not an issue. Next, we will look at Low's centrifugal products, including blowers and blower wheels. Low parts blowers are forward curved blowers, which means that the blades of the blower wheels curve in the forward direction. This illustration shows the various parts of a forward curved blower, along with alternate terminology you may hear when discussing parts. For example, the housing may be called the scroll, and the blower wheel may be called an impeller or squirrel cage. Low offers both belt drive and direct drive blowers. The difference between belt drive and direct drive is how the blower wheel is driven. Belt drive blowers are indirectly driven by the belts and pulleys. The motor shaft turns the motor pulley. The motor pulley turns the belt. The belt turns the blower pulley, and the blower pulley turns the blower shaft, which drives the blower wheel. Direct drive blowers are directly driven by the motor. The motor shaft turns the blower wheel. The advantage of direct drive blowers is that there are fewer moving parts. Most residential furnace applications today are direct drive. Low's belt drive blowers include all components needed to install the blower, including motor mounting bracket, housing supports, and mounting hardware. Our belt drive blowers can be installed in any orientation. The image on this slide shows the breakdown of components in a direct drive blower installation, including belts and pulleys. Although most residential applications use direct drive blowers, belt drive blowers are common in commercial and industrial applications. Low's direct drive blowers include the adjustable motor mounting bracket and housing supports. You will notice that there is no shaft on the direct drive blower. This is because the motor shaft directly drives the blower wheel. The image on this slide shows the breakdown of components in a direct drive installation. There are significantly fewer parts in a direct drive installation, which is a primary reason why this blower is the preferred option for residential furnaces. Repairing an old blower can be time-consuming and expensive for the contractor and their customer. Old bearings may be worn and sloppy. Wheels may be caked with grease and grime, and housings may have vibrated loose at the welds. Replacing just the wheel may not eliminate all potential problems. Installing a new blower can prevent callbacks and save money in the long run. To replace a blower, first identify whether it is direct drive or belt drive. If direct drive, determine the rotation. Next, measure the existing blower and check your Low catalog for the closest replacement. The overall dimensions must fit into the furnace cabinet, but the output dimensions K and E are most critical. Check the performance of the replacement blower in Appendix B of your Low catalog. Also in Appendix B are drive charts for Low direct drive blowers. Contact your Low sales representative or our customer service team for assistance in reading the drive charts. Lau's forward curve blower and blower wheel description follows a basic format. The first 2 to 3 characters indicate whether the part is a wheel or blower. BL generally indicates a complete belt drive blower, and W plus H is a direct drive blower. Blower descriptions will often show additional letters after the series letter A, such as CD or CE. These letters correspond with the contents of the installation hardware pack that ships with the blower. CD and CE blowers are interchangeable, and the Laupart stock blower will always include all necessary installation hardware. Wheel descriptions vary depending on whether they are belt drive or direct drive wheels. Our belt drive wheels show the letters WHL at the beginning of the description, followed by diameter, width, and other pertinent information. Our direct drive 9 to 12-inch blower wheels will show the diameter and width first. One other difference is that direct drive wheels will show CLW as the designation for clockwise. This is due to variations in labeling software and does not impact the performance of the wheels. Single inlet blower wheels are available from Lau in sizes from 3 13/16 inch diameter through 9 15/16 inch diameter. Larger single inlet wheels are available as direct replacement for Lau FGP blowers. Lau's direct drive blower wheels in 9 to 12-inch diameters are designed for lower pressure residential systems. The wheel is constructed by expanding the center disc into a dovetail feature in the blades. Lau's belt drive blower wheels are available in 9 to 20-inch diameters for residential and commercial applications. Our belt drive wheels are bidirectional, which means that they can be used in both clockwise and counterclockwise applications. The belt drive wheels feature the press lock design originally patented by Edgar B. Lau in 1928. The wheels are constructed by positive compression of the blades to the center disc. H wheels are available in 20-inch to 36-inch diameters for high-pressure commercial and industrial applications. The blades are welded to the center disc and end rings, and these wheels are bidirectional for use in both clockwise and counterclockwise applications. H wheels are available by special order. Double inlet blower wheels are wheels that are open on both ends. Direct drive double inlet blower wheels are produced in either clockwise or counterclockwise rotation. To determine rotation, view the wheel with the hub facing you. Determine which direction the blades of the wheel curve. If they curve to the right, the wheel is clockwise rotation. If they curve to the left, it is counterclockwise rotation. When replacing a direct drive blower wheel, it is also important to determine whether the hub is on the concave or convex side of the center disc. This is necessary as motor shaft lengths vary. Single inlet wheels are open on one end with the back plate on the other. To determine rotation of a single inlet wheel, view the wheel with the back plate facing you. Determine which direction the blades of the wheel curve. If they curve to the right, the wheel is clockwise rotation. If they curve to the left, it is counterclockwise rotation. When replacing a single inlet wheel, also make note of whether the hub is inside or outside of the backplate. To replace a blower wheel, start by measuring the diameter and width. Determine whether the wheel is direct drive or belt drive and double inlet or single inlet. Belt drive wheels will have hubs and center discs on both sides of the wheel. Direct drive wheels will have one center disc and one hub. Double inlet wheels are open on both ends. Single inlet wheels will be open on one end with a back plate on the other end. For direct drive or single inlet wheels, determine the rotation, clockwise or counterclockwise, using the method shown earlier in this presentation. Measure the diameter of the bore in the hub to ensure the wheels will fit on the motor or blower's shaft. Most direct drive residential replacement wheels have half-inch bores. Note that all LAO wheels are keyed to accommodate any type of shaft. In addition to blowers and wheels, LAO offers a wide range of parts and accessories, including motor mounting brackets, bearings, and shafts. Refer to your LAO catalog for complete selection. Also available from LAO are Gates brand belts and pulleys, tools, and gauges. Our customer service team can assist you with selection of Gates products. There are many potential causes of failure in HVAC systems. Let's review some of the more common causes. Never test the system with the furnace cabinet open. It is easy to get busy and distracted during service or installation and forget this key final step. When furnace filters are not changed over a long period of time, they can become clogged with dirt, as shown in the picture on this slide. Coils could also become dirty over time if not properly cleaned. We have seen situations where a fan was installed backwards, leading to failure. For example, installing a clockwise fan in a counterclockwise application. Check for loose and damaged parts and obstructions in the ductwork. Finally, always replace the propeller when servicing an outdoor condenser unit. Placing an old fan blade on a new motor can lead to expensive motor failure. A common complaint we hear from contractors is excessive noise. Noise is often caused by vibration due to resonant frequency issues. Solving these issues requires changing the motor or changing the fan blade. Other issues that can lead to excessive noise include cracked, damaged, loose, or improperly installed components. Replacing a swept blade with a condenser fan blade can also result in excessive noise. Thank you for joining us for the LAO Air Moving School. For additional assistance with LAO parts, email our customer service team at info@laoparts.com or contact your local LAO sales representative.